Hello and welcome to this Esri Dev Summit presentation on using Koop to connect any data source to ArcGIS. My name is Rich Gavouge. I am a software engineer at Esri. I work out of the Washington, D.C. R&D Center. And myself and Haliang Yu, another software engineer, are some of the main contributors to the Koop open source package of software. So thanks for being here, and let's get started. What is Koop? Koop is an open source web server used to extract and transform geospatial data on the fly. That's it in a nutshell, but we can go into a little bit more detail by describing it as a RESTful web server written in Node.js. As noted, it performs geospatial data extraction and transformation. So if you have geospatial data in one format and you'd like to get it into another format, you can use Koop, and you can do this on demand and on the fly via HTTP requests. One important aspect of Koop is that it has a plugin architecture. So there are plugins for accessing data, and then there are plugins for transforming that data to a different format. One of the important plugins for transforming data is the geoservices output. And the geoservices output is what allows Koop to serve data to ArcGIS clients. ArcGIS clients use the geoservices API spec for their HTTP requests, and since Koop understands geoservices, it can feed data to ArcGIS clients. There are a lot of other published plugins for Koop on NPM. So for example, there are plugins for accessing data on GitHub, or file GeoJSON data, or CSV data. And then there are plugins for transforming what's coming out of Koop into things like vector tiles or geoservices. Important to note that it's pretty easy to write your own plugins for your own specific needs. And finally, just a note on licensing, Koop is Apache licensed and it's free to use. Let's talk about some of the basic concepts when you're working with Koop. There's what we call Koop Core, and that is basically just a wrapper around a lightweight Express.js server instance. And it handles the registration of plugins, listens for requests, and manages data flows across the plugins. Then there is a provider, which is one of the plugin types. And providers are used to connect Koop with remote data sources. They don't always have to be remote. They might just be local files, but in many cases, they are a remote API. So providers connect with those kinds of data sources. There are then output plugins, which transform data flowing into Koop into specific output formats. And as noted before, output formats may be just a particular specification of JSON, or it might be something like vector tiles. There's also a cache plugin, and the cache plugin is used to store data so that the data doesn't always have to be fetched from the remote data source. So for instance, if you have subsequent requests that are exactly the same, you can get it from get the data from the cache instead of from going to that remote API each time. This is a very generalized diagram of how Koop plugins are related and how data flows from providers to outputs. On the left side, you'll see a collection of some of the different Koop providers. There are many different provider plugins that are already published, including Elasticsearch and GitHub and those that you see here. Those provider plugins funnel data through the Koop server, which passes it on to any of the registered Koop output plugins, which include geoservices or vector tiles, so forth. Those output plugins will eventually pass data on to any of the clients that initially requested the data. And as noted before, and as implied by the title of this talk, ArcGIS clients are able to connect to Koop because of the geoservices output plugin. Let's talk about the Koop request lifecycle. So starting with a client, this might be an ArcGIS client, a request is made to the Koop server, and that Koop server points the request to the output, which passes the request on to the provider's getData method. That getData method in the provider will make the request to the remote API. The data is fetched and sent back to the provider, where it is translated into GeoJSON. Once translated into GeoJSON, the provider hands the data back off to Koop, goes to the output plugin, and the output plugin may do some additional post-processing. This is generally transforming that GeoJSON into whatever the output specification is. It might also include things like filtering or reprojection. But for example, if this output was a geoservices output plugin, it would post-process the GeoJSON, turning it into Esri JSON, which is then sent back to the client. If you're using a cache, the Koop request lifecycle is a little bit different. In this case, the client, of course, still sends its request to the Koop server, but the output, instead of going directly to the provider to ask for the data, will first go to the cache. And if the cache doesn't contain data from a previous request, then it will go on to the provider, and of course the remote API. And on the way back from the provider, that data will get stored in the cache plugin before sending it on to the output and then onward to the client. The next time that same request is made, it'll end up going to the cache and finding it. And therefore, it doesn't have to go to the provider or the remote API for the data. Instead, the cache will just deliver that data back to the output and then back onto the client. The cache is controlled by a set time to live, so this won't happen indefinitely. It'll just occur until that time to live is exceeded. Let's try to illustrate what's going on with outputs and providers in Koop. An output essentially provides one or many public APIs for a client to access. And these output plugins are paired with each registered Koop provider. And they're linked through the Koop endpoints. So at the bottom here, you'll see an example route. And on the left side of the route is the provider segment. It's essentially the provider's namespace and any route parameters that the provider has been configured to use. In this case, the ID parameter. On the right side of the route is the output plugin segment. And so those are defined by the output. Put these together and they link a specific request to a particular output plugin and a provider data source. I'm going to talk a little bit more now about output plugins, provider plugins, and how Koop links them. So An output plugin provides one or many public APIs for the client, and it does this by defining a set of routes and a set of handlers for those routes. A provider, on the other hand, provides a method for fetching data from its associated remote API and then transforming the data coming back from that remote API to GeoJSON. When output plugins and provider plugins are registered, they are combined to generate a compound URL that is made up of a provider fragment and an output fragment. And you can see this in the example route at the bottom of this slide. On the left side, we've got the provider fragment, which includes the provider's namespace and any route parameters that the provider's been configured to use. In this case, it's been configured to use a route parameter called ID. On the right side, we've got the output fragment of the request URL. This is one of the routes defined by the output plugin. It's useful to illustrate what happens when you register different combinations of output plugins and providers. In this example, we've got one output plugin, the GeoService output plugin, registered with our instance of Koop, but we've got two different data providers, the S3 provider and the CSV provider. And as a result, you would get two of our example routes that we just discussed. You can see them here below. The output plugin fragment on the right side of this string is identical, but the provider portion is different. There's different namespaces for each of the providers. Alternatively, you can have a situation where you have a single provider and multiple output plugins, which is what's illustrated here. We've got the GeoServices output plugin, but then we also have a vector tile output plugin, and we have one provider plugin, a CSV provider. So in this case, all of your routes will have a single provider namespace, provider CSV, but you'll have different output plugin routes attached to that namespace. This is some of the actual code that could be used to make that last example where we had the GeoServices output plugin, the vector tile output plugin, and the CSV provider. So you'll notice here that we pull in the CSV provider and the vector tile output plugin. We create a new Koop instance. We register the vector tile output plugin and we register the CSV provider before then starting the Express server. What you don't see is you don't see us pulling in the GeoServices output plugin or registering it. And that is because Koop ships with that output plugin registered internally. So you never have to register the GeoServices output plugin. It is taken care of internally by Koop. And once you start the server, you'll see some console output that lists all the routes provided. And you can see here that the GeoServices output plugin routes are there, even though the plugin wasn't registered explicitly. As noted before, there's many different providers that you can use that are already published on NPM. There are CSV providers, GeoJSON, S3. There are providers to connect to Google Sheets and Socrata, Yelp, and many others. You can Find them by searching for Koop providers on NPM, or visit our documentation page for a list of both officially supported providers as well as third-party providers. And of course, you can create your own. Outputs, similarly, we have a few output plugins that are officially supported, including the GeoServices, as well as vector tiles, and we have some other experimental providers that are somewhat of works in progress. Again, you are able to create your own output plugins and register them in your own Koop instance. As far as deployment goes, Koop is just a simple Express Node.js web server. So it really can be deployed anywhere. And we have deployments using Docker, Heroku, AWS and AWS Lambda, Kubernetes, and many others. If you're new to developing for Koop, you may be wondering how to get started. And I'd encourage you to look at the Koop documentation, but you should also look into the Koop command line interface. The Koop CLI is a command line tool for Koop developers to quickly set up a Koop project. And that might be setting up a Koop instance, application instance, or it may be setting up a plugin development project. The Koop CLI can also run your Koop project as a development server for testing, and it works on Windows, Mac, and Linux. The Koop CLI is really easy to use. You simply type in Koop new app and then the name of what you want your app to be called, and it sets up a Git repository as well as the file structure needed. When that is finished, what you'll want to do is cd into that application directory, and you'll notice the file boilerplate is been generated. And then you can add a provider to that instance by simply doing Koop provider and then the name of the NPM package for that provider. That will both pull down the NPM and register it with your Koop instance. And then you can do Koop serve, which will start the demo server. And here you can see some of the routes that have been generated. If you want to build your own Koop provider, the easiest way to get started on that is to use the Koop CLI to create a provider project from a template. Just type in Koop new provider, and whatever the name of your provider is going to be, and the Koop CLI will generate a project directory with all the needed files and a associated Git repository. The file structure will look something like this, where you have a source directory folder, and then an index and a model JS files. You'll want to modify the model.js file. The model.js file contains a model class, which has a getData prototype method. The getData method is triggered by Koop when an output plugin requests data. You'll want to add code to this getData method that executes a fetch to your remote API for the required data. And when that data comes back, you'll want to transform it into GeoJSON before passing it on to the callback function. In summary, Koop is an open source and lightweight ETL solution that provides on-the-fly transformation of geospatial data from one format to another. It comes with a GeoService output plugin that allows ArcGIS clients to connect to data sources that can't be supported by ArcGIS Server or ArcGIS Online. There are many already published Koop provider and output plugins that are ready for use, and you can see a list of them on the Koop documentation pages. Koop really can be deployed anywhere. We've deployed it in the cloud as well as on local machines. If you're getting started with Koop, some development may be necessary, particularly if you're creating a new provider or output plugin. But Koop's plugin architecture and CLI can reduce a lot of the effort. If you're looking for some additional resources, please check out the koopjs.github.io homepage. We've got a lot of documentation on there, both on usage and development, that should be useful. Also check out the Koop CLI GitHub page. On the Koop GitHub organization, we have a lot of repository-specific documentation, and you may want to look at some of the example apps. Thanks a lot for watching this presentation, and please reach out to us if you have questions. We try to respond very quickly to GitHub issues, so maybe we'll be in contact there. Thanks again.